Hello, this is Paul Massengill with Luminex Software. I'm a systems architect and data analyst with Luminex, and I'm here today to talk to you about what we call MDI SLP. It's the ability to move all of your SAS processing to a connected coprocessor, if you will. So you're still running everything from the mainframe, but you're able to run things much faster and not impact your mainframe CPU. And our customers have been very excited about this. Everyone that's put it in just can't believe the results that they're getting. And I'm specifically bringing this to you today because it will allow you as a capacity planner, performance tuner, data analyst to be able to achieve things that you just didn't believe would be possible because of the constraints of being able to run SAS on the mainframe. So let's go into this a little bit. What we're going to talk about is why were we even considering using SAS offload process. Then I'm going to go into quite a bit of detail about how the process flow actually happens, how it works, how can we actually do this. Then I'm going to talk about what it is required if you're going to actually do this migration. What's the preparatory steps that you want to do to get ready for it? Then I'm going to talk about how it actually frees up your data analytics and what it enables you to be able to do so that you finally have the time and the resources to start finding things out about your data that you're too constrained to be able to do within the current limitations on the mainframe. So let's start out. Why are we even considering it? Well, SAS burns a lot of CPU, so it can help you avoid a costly mainframe upgrade. The SAS license on the mainframe is quite expensive. A lot of people try to constrain it to smaller LPARs, and while that does help from the cost of the licensing, it doesn't really help from the standpoint of you need to be able to get your jobs done. So a lot of people are looking at trying to move all, or at least this heavy hitter SAS application off the mainframe and free up CPU cycles and also get their job done faster. We have had a big push from a lot of our customers. They've gone into tailor fit pricing. They want to get data processing that's not revenue generating, and a good example of that is MXG with SAS off the mainframe. At the same time, this will give you an opportunity to very easily modernize your SAS processes and potentially integrate it with other data analytics tools such as R and Python with NumPy and some other tools that are already written and very easy to use actually on the Open Systems platform. And all of this we're really doing for one purpose, to allow us to do more searching through our data, more ad hoc reporting and analytics, find more value in this data or new insights into how we're running our business that we just couldn't do before because of different constraints. So let's look at all these things. First off, this is a survey that we used from, you see the footnote at the bottom. It says 55.8% use batch mainframe to analyze their performance data. Now think about this. You're analyzing your performance and your capacity reporting data from the mainframe by using the mainframe, and frequently you turn out to be some of the biggest consumers on the mainframe as you're doing it. Of those people that are doing this still on the mainframe, MXG has about 85% of the market share. And so I'm going to be talking about MXG and SAS through this because MXG is very easy to very quickly, like 2-3 days, you've got it moved off the mainframe onto this coprocessor. So it's a really excellent use case. I just used an example report of one of our customers that we did all this analytics for, and SAS was their number 6 top CPU consumer. I've had other customers that it was number 1 and number 2, but this was just a fairly recent example. And from that same customer, then we went in and we said, well, look, of your top 10 intervals of CPU consumption, what was the top consumer during those times? And you'll see that SAS was, up there on several of these. So it was greatly contributing to their peak. So what are we actually talking about using? Well, your SMF data that would then be fed into MXG and SAS is produced on the mainframe. So we're not talking about changing that. It's still going to be produced there. But what we're talking about changing is taking that SAS language execution, moving it off host to the coprocessor. All the MXG PDB creation and the reading the PDBs to create reports and the trend reports, etc. All that stays off host. The storage associated with it, as well as the CPU consumption. All the report distribution, did the job run successfully, what's the return code, SAS log, SAS list, any reports that you're generating, all that can come back to the mainframe. That's not going to change. In fact, if you submit your jobs either through a scheduler or from your own control library and you execute, you're going to look at it in SDSF. You're going to see that it's executing, but it looks like it's not burning any CPU cycles. Looks like it's hung. Looks like it's not doing anything for 3, 4, 5 minutes, however long it takes to execute the SAS code. And then all of a sudden everything comes back, and when you look into your output in SDSF, everything that you're used to seeing, literally everything you're used to seeing, is going to be there. So your sysout, your JES, it will be in the JES spool along with your JCL, your SAS list, your SAS log. Everything is there for you to look at, including return codes. So if you have a series of jobs, of which SAS and MXG processing is only one, and they're waiting on proper return codes to come back, whether to abend and have someone look at it and fix it and process, or to go ahead and kick off the next job because everything was successful, that stuff's going to continue to work. That's not going to change. All right, so why is this any different? How can we move that much data off the host quickly enough to actually make it work? Because we're going to be using FICON. We're not going to be using TCP/IP. The amount of data that we're talking about moving for many of my customers, they're moving 1.5 terabytes or more per tech when they're doing this per day. They can't do it via TCP/IP. It's just too slow. It's prohibitive to try to move that amount of data in a timely fashion and get the reports back. So we're doing it all via FICON. Not only FICON, but we're doing it via multiple FICON channels so that we can move this data very fast, both from the mainframe to the coprocessor, from the coprocessor back to the mainframe. And that's the true differentiator and why this can actually work. Here's just a quick comparison that some of our customers have shown when they were moving data in different formats. In this case, it was trying to move it to SFTP as opposed to an NFS mount, which is what we're usually using with the MDI SLP as an NFS mount, which is even faster. You'll see that they're using a lot less resources as far as CPU burn to move things via TCP/IP, and it's also happening a lot faster. So now let's talk about what's really going on. Well, you will actually submit your job on the mainframe, and that's optional. Once you get used to this environment, you may log directly into the SAS box and run your jobs there, and that's fine. But if you're running through your like a CA7 or any other scheduling package on the mainframe, then it'll be submitted on the mainframe. You'll be executing LUMXPROC instead of executing SAS, and that lets us know, hey, we need to intercept this and actually run SAS on this external server, this coprocessor. Get all the data moved via FICON. We convert it for you. We will store it then on a shared NFS mount with the SAS server, and then we will actually tell the SAS server to execute the code for the SAS job or the MXG job, etc. It will run. It will create files for all those things that you're used to, like your execution JCL, which would include the SAS log, SAS list, all those things. We'll grab that, bring it back with the reports, back to the mainframe, and then we'll either create data sets the way you do today, if you're creating external data sets for these reports, or if everything's just staying in your sysout going into SDSF, then we'll bring it all back into SDSF. Same way that you're doing today. It's just all the execution of all those CPU cycles are happening externally. And one of the greatest values that we're finding when we're doing this, and I found personally because I've been running a lot of jobs like this on these servers, is and I haven't been able to evaluate it to determine exactly, but I think it's because the sorts run much faster. I have a lot more memory available in these boxes, and the sorts tend to stay almost entirely in memory. And so with every different case that I've used, the worst improvement that we've had was 4 times faster. And in some cases, we're seeing it 16 times faster. So essentially, take a job that was running 8 hours, you're going to run it in 30 minutes, maybe less. The worst case you're going to get is run an 8-hour job in maybe 2 hours or less. But I haven't seen any jobs run 2 hours out here that were 8 hours to start with. Usually they're in the 25 to 35 minute range to complete. And they're exactly the same output as you get when you run on the mainframe, but you save all that wall clock time. And that wall clock time is so important because now you can actually accomplish something, find out if you got your answer or not. If you don't, you can actually rerun it instead of waiting until tomorrow to rerun it when you come back into work again. So anyway, how's this all working? How does it really come out? Well, you can even have it as a single step in the job. So the step before it's doing something, taking about 5 minutes. Then you have this 2-hour step that's your SAS code, running, churning, sorting, producing all of these reports, different analytics, and then you got your next step. Well, now we're going to intercept that. The first step still is going to operate on the mainframe. The next step is going to be shoved off. We're going to run it much faster. We're going to bring everything back, and then the next step will continue. So that's as easy as it is. We're just literally moving the execution specifically of SAS off host. Now, this is an eye chart. I understand that, but we're going to step through it, and then you go, oh, well, that's not so bad. So what would happen if we're doing normal MXG execution, reading in the SMF data, and getting the PDBs updated for the day? Well, your JCL is going to transfer the SMF data to the MDI appliance where we're going to convert it and have the data ready for you. The JCL that was executing SAS is now going to execute LUMXPROC, and you're going to pass a few parameters to it, just telling us the data sets that you're trying to use and things like that. Same stuff you're doing today in DD statements on the mainframe, but now we're going to link those DD statements to a PARM that links it to a data set that's named in a different format, because we name the data sets in a Linux format on the coprocessor. Then we're going to pass that job over. There, the MDI will read the data sets, pass the job parameter over to the SAS language processor on a separate server. It will actually execute using MXG, same way you're doing today. You're going to create all of your final output, and then that output can either stay out there, it can be shipped out as a PDF or any other format that you're using today via email, or you can send it all back to the mainframe, create data sets there the way you do today, or just send everything into SDSF. So it's really a pretty simple flow. Everything is still happening on the mainframe, still controlled by the mainframe, with the exception of the actual SAS execution, and then all the outputs coming back to the mainframe. So, are you going to have to make big changes to your jobs? Well, actually, the SAS code, with the exception of lab name, file name, and just a couple of formats that are listed in SAS documentation, because we're actually running SAS on Unix, and they list a couple formats that do not carry over from the mainframe to Linux. But short of that, you're not going to make changes to your code. What you're going to make some small changes for is you're going to, instead of executing SAS, now you're going to be executing LUMXPROC, telling us to, hey, take care of that SAS execution on another platform. And then we're going to make some reference changes in your DD statements so that they actually point. You see here, SAS list is pointing to data set name, ampersand SAS list. When we look down here, it's saying the DD reference that you're looking at is now actually, and we name the data set name out. That's the difference that we have to make. We actually have to change the format of your naming from high level qualifier dot some other qualifier dot last lower level name to the dataset naming standard that you use on Linux. That's really the only changes that you make. So again, what are we going to expect from doing all this? Well, it's going to be more secure. We're not sending data over TCP/IP, so all over FICON. You can move the data very rapidly because we can use multiple FICON channels simultaneously, so you can move the data very quickly in and out. No more data silos, if you will. You can combine this with other data throughout your enterprise. You can make it available for other analytics packages throughout your enterprise. It's just very useful to be able to interchange terabytes and petabytes this rapidly with the mainframe and with your distributed systems. You're going to take all that CPU overhead that you were burning on the mainframe away. It'll be happening on a smaller Unix box. And then the end result is you can potentially avoid expensive mainframe upgrades and or expensive software licensing costs from having to use it on bigger LPARs, because you're not burning it, those MIPS, you're not having to use a big LPAR on the mainframe anymore. I frequently get asked, well, what about MXG? Do I have to buy a new license? No, MXG actually is a site license, and so if you have it already on your mainframe, you can move it over, copy over to your Unix box. And by the way, MXG takes care of some things, like there's no GDG file structure on Linux, so they do that. They take care of that for you by renaming subdirectories, and they take care of that within the macros themselves, so you don't have to worry about it. And then you can either reference directly to those dataset names, or you can use the macros that they have already built to pull today's data or yesterday's data or last week's data. So you don't have to even know what the subdirectories are really named in real life if you don't want to. You can just use their macros. Now, if you're going to migrate into this environment, then there's some things to think about. You're going to have to do discovery of what are your current SAS estate, what are you actually taking up on the mainframe today. You're going to want to analyze this and see what the impact is. You know, are there other jobs using these databases and things like that that are outside of your group? You're going to want to take this time to optimize. In every single implementation we've done so far, customers have not taken advantage of the latest and greatest macros and capabilities of MXG, as an example, or changes in the SAS language to make things run faster, easier to understand, that kind of stuff. But now, since you're going to go ahead and touch the code, it's a good time to look at it and see if there are a few tweaks you could make. I've saw one customer example where they had well over 1,000 lines of code, and we replaced it with about 6 lines of SAS code with MXG, where they were doing their own trend database creations, and they had all the code associated with that. They didn't need to, because that's something that's really built into MXG now if you just take advantage of it and turn the parameters on. And so we made that change for them, and suddenly there's this job that they would agonize over, because if it broke, nobody that had written it still worked at the company anymore. And instead, now it's just handle it with MXG, and if there's a problem, you can call MXG support. So they were very happy with that. And then we look at what's the process we're going to take for migration, usually run in parallel for a little bit and get used to the new environment, and then swap over. And then what new development things can we actually take on because of this? So first off, for the discovery, you're going to want to look at all the assets. Where are your user, who are the users that are actually using SAS? How often is SAS being executed? One of the implementations that we did with this, the customer was concerned because there were thousands and thousands of executions of SAS, and they're like, we can't go in and change that many jobs. You got like 16,000 executions of SAS. We can't go change 16,000 places, even if it's just a little change. It's too humongous. And then we looked at it, and we're like, well, you're executing SAS that many times, but it's the same jobs being executed over and over and over. So there were well less than 300 jobs that they had to actually go in and change to completely convert their entire SAS environment. And most of those were very simple changes. So it can be daunting until you start actually looking at it and analyzing it a little bit. You want to figure out what are the resources that you're actually consuming with this. Is it of value for you to move SAS? If you're barely using SAS and you're not burning any CPU, and when you do a list of all the heavy hitters for CPU consumption, you're listed number 120 out of 129 applications, well, then you probably don't want to do this. But in every single place that we've analyzed, SAS is 6 or higher as far as CPU consumption. Then consider your migration. Do you want to take care of actually identifying all those resources and changing the JCL links yourself? Would you like some help in that? That's something that you're going to need to consider. And then let's talk about the benefits for you. You as the capacity planner, the data analyst, the performance tuner, whatever your job title is and whatever your function is, your jobs are going to start running anywhere from 4 to 16 times faster. So when you need to get an answer to a business problem, imagine getting it that much quicker, because we all know sometimes you run the job, you get the report, and you go, you know what, that's not quite right. I need to change this. I need to tweak this. I need to sort it a different way. I need to do something just a little bit different. It's an iterative learning process as we go digging for these chunks of gold, if you will, that's this information hidden within this volume of data. But if you can get it that much faster, make your changes, run it again, get it back again that much faster, think about how much quicker and how much better you can actually be in your data analytics. So another thing that happened to me, I've been doing this as a customer for a long time before I came over to Luminex, running SAS, and used to, when I would get requests from the directors at the company, I worked for several different banks, and then I put together my analytics and I run it. Then I get a call an hour or two later from the operators going, why are you the biggest CPU consumer on the mainframe right now? We're going to have to put you into, we're going to have to constrain these jobs so they're not using as much CPU. We're going to put them in a different class. We're going to, and they had to. I mean, true production work, if you will, is more important. But then that made my jobs run slower. And sometimes when you're reading through lots of data and trying to do an analytics thing, like a couple of times I was asked, what would be the impact on our CPUs if we consolidated these CPUs and this storage to a different data center for DR? Well, I would have to run jobs that would read a lot of data, sometimes they run 16, 18 hours. And then when they get put in a different class and given less CPU, they'd run even longer. And then, a day or two later when the job finishes, you start looking through the output and you go, what if I were to change it this way? And now you've got to rerun the job again. Well, what if when you were doing those type analytics requirements, you had your own SAS server or the ability to run on this off-host SAS server, and nobody's going to change your priority. Nobody's going to constrain your CPU. And by the way, you're running 4 to 16 times faster anyway. How much better can you do your job? How much quicker can you get those answers back to those directors that are directly asking you for your input? What's the impact of this going to be before we make this decision? What if you can start getting those back much, not only quicker, but with clearer results, because you're not afraid to run it 2 more times to try and check out your results or find another alternative, because you can actually do it. You're not burning that much CPU on the mainframe. What if when you get to a certain point with your analytics with SAS, you incorporate some additional analytics using R or Python with NumPy or some of these other packages that are already written that really go out and help you search through your data and come up with options. It's very easy now that you've got that data off host on a platform where you could potentially install just R and Python directly on that platform itself and run it, to do alternative analytics and find those answers, those nuggets of gold and information within all that data. Something else, once you get used to this environment, you can run your ad hoc SAS jobs directly from the SAS server without JCL and all the other stuff on the mainframe. That's your choice. I tend to do my development directly on the open system server until I get my SAS code to where I want it. When I've done all the development work that I want to do, and now it just needs to run every day and produce a report for my manager or for the director or whoever, that's when I go back to the mainframe with the already written code, wrap the JCL around it, put it into the scheduling package, all those steps that you have to do, and then let it start executing that way. But while I'm doing that rapid iterative development process, for me, I find that I work much better and quicker directly on the open system server. And then the big thing with all this, while you're doing this process, while you're running things off host, this is allowing you to save a tremendous amount of mainframe CPU. And by the way, if you're the capacity planner, the performance tuner, brag about it. This is your opportunity to show, hey, look, this much was happening on the mainframe, and we've been able to pull it off. I've had one example, a customer that they saved over 4% of their total usage of CPU on their mainframe. The best part is it was about 16 to 20% during a peak that they were trying to get down. So it had, the global impact was only 4% over a 24-hour period, but the specific impact during a peak was even more significant. So if you can save that type of resources for your company, don't be quiet about it. Make sure that everybody knows the impact that you've been able to achieve with this. Brag about it. One other benefit of this, I'll just mention briefly, is once you have this process set up, if you need to get this data out into other formats, into other servers, it's very easy to do. The highway, the data movement highway, if you will, is already in place. You could send this data directly into Hadoop. You could be sending it into Kafka. You could be sending SFTP transmissions of reports or PDFs or portions of the data if you need to other locations within your enterprise, and it's already on an NFS mount. If you need to share it with some other additional servers, it's there. So think about that as well when you're trying to determine what's the best way. Is there value in looking at this alternative in the way that I do data analytics? How can I get more out of this data without consuming more resources on the mainframe to do it? Well, I'd like to thank you for your time today. I hope this has been informative. Again, I'm Paul Massingill with Luminex Software. If you have any questions, if you see any benefit to this and you'd like to actually, go more in depth into it, I'm always happy to discuss that with you. Thanks again, and I hope you enjoy Share this week.